Do you need me to solve the problem? Solution is easy. So we have a source antenna with gain of 10, right? And receive antenna with gain of 20. Is that so? Yes. The distance is 500 meters and the power transmitted is 100 watts. So what will be the there are two ways to solve it. What we miss? The frequency. F equals 150 megahertz. So if you have the frequency, the first thing if you have antenna problem is to convert it to the wavelength. Lambda equals
2 meters.
2 meters. So the first thing to calculate is the power flux density. Power flux density is how much? The transmitted power, 100 watts, times antenna gain, 10, equals 1000 over 4 pi r squared equals 1000 over 4 pi times 500 squared.
Isn't 4 in the pi on square too?
No, not yet. Not yet. The second thing is to calculate the effective area of the receive antenna. A effective received is lambda squared over 4 pi times gain of the receive antenna. I think here is a mistake in the formula. Should be, yes. Here is the lambda squared over 4 pi times gain of the receive antenna, which is 20. And the last thing left is to multiply this by this. Easy and logical. And what all the students do, they skip these 2 steps and go directly with the Freeze formula. Just put the numbers. Sir, we have the answer. Goodbye. But as engineers, we must know the science behind. So this formula doesn't come from the sky, just drop it. It is not empirical formula, it is delivered through logic and calculations. Yes? Please.
Can you explain your solution one more time?
Yes, of course. The source on a distance with power P transmit and gain G transmit will produces power flux density with value P transmit times G transmit over 4 pi distance squared. Mistake. Here is the correct. P transmit, G transmit, 4 pi distance squared. This is the power flux density at the input of the receive antenna. Right? Do you understand why?
Okay, just you can.
We have power transmitted here and gain of the transmit antenna. So power times gain will give us the power strength at the maximum, direction of the maximum directivity, maximum gain of the antenna. So this antenna grabs the power and directs it toward this direction. So transmit power times the gain of antenna give us in this direction the effective power, so-called. Equivalent is isotropic radiated power. And how much is this evaluated? It will be the transmitted power times the gain of the transmitted antenna over the sphere with radius r. And the area of the whole sphere is 4 pi radius squared. Is everything clear so far? Yes. And now, how we do extract the power from the space? We put something to trap it. And what can trap it? Antenna can trap it. If we put a shirt, it won't trap it, but the antenna will trap it. And antenna traps the energy, extracts the energy with its effective area. So now the problem is how to calculate this effective area. And effective, Weissman established that effective area of the antenna is directly related to antenna gain and wavelength. So we estimate the effective area of the receive antenna as lambda squared times gain of the antenna over 4 pi. So this is the effective area of the receive antenna. And we multiply the area that we are taking the energy from times the power flux density in watts per square meter. We get how much power will enter the receiver.
Can I ask a question?
Absolutely, yes.
So the effective area is the place between the transmitter and the receiver?
Effective area is a virtual area from which the receive antenna extracts the energy. And usually it is portion of the aperture, the real physical aperture of the antenna. So usually it's less than that, because antenna is not so effective. It can receive at least the energy that comes to its physical dimension or less, but no more. And to know how much gain, this is how effective area is calculated. Gain and wavelength. This gives us the area from where the antenna can extract the energy. It's an imaginary area, you know, we don't see it. But actually this is how much the antenna can take the energy from.
I just wanted to know if this area is all between the.
You know, it's on the surface of antenna opening. Not between them. That's the surface of the opening of antenna aperture. Very good questions that show me that you are very close to the point. Good. Everything in our world works or it is governed by this law. Everything. Starting from hearing to vision to communications, everything. If we invent, as I said, space-time tunnel to pass the energy through, lossless, we can produce the electricity here and consume it here without any loss, which will be good, but we cannot do that so far. And the answer is 2 milliwatts or 3.6 dBms. dBm is typical radio engineering unit, which means decibels against 1 milliwatt. And this will be tomorrow thing. Now, 5-minute break, and if somebody has a laptop, it can get it ready.